All right, well, hello everyone. Welcome back to the latest virtual office hours. This is really the first time I've done one in quite some time that isn't immediately preceding a major or disruptive weather event in some way. So this one can be a little bit more summative and reflective and sort of forward-looking because there is finally a meaningful break. And actually, I think it's probably going to be more than a break. It does look like there is, as you might normally expect to happen as we head into April, a major shift in the pattern towards generally drier and warmer conditions, essentially statewide. But there is one more interesting and very cold system to get through next week, although it doesn't look like it's going to produce very much precipitation or wind, so I'll talk about that in a moment. But since last we spoke, another significant storm system in California, which this one behaved a little better than some recent ones in the sense that it produced largely the impacts that were expected in advance, unlike the one that preceded it, which brought far more severe rain and wind impacts to the Bay Area than had been initially anticipated. This most recent storm did, in fact, quote-unquote, bomb out, but it did so well off the coast and much farther north, essentially well west of the Oregon-California border over the open ocean, and in doing so brought, again, widespread rain, fairly low elevation snow, and some gusty winds, which brought some more trees down, but not nearly as many as the round that preceded it in Northern California. So there were, again, some fairly intense thunderstorms in the Central Valley, although this time, as far as I'm aware, no tornadoes and limited severe thunderstorms. No new spin-ups that I'm aware of in Southern California either, although again, some pretty spectacular thunderstorms did pop up as expected in that relatively cold and unstable air mass yesterday and the day before. So that storm was unusual in that it was fairly robust and cold for late season, but in a broader context, not especially remarkable, especially given what's happened recently and so far this winter. But it was remarkable for one thing, I think, which is that it added even more snow water equivalent to the already record-breaking, essentially 300% of average for the seasonal peak Southern Sierra snowpack. So believe it or not, we have even more snow water stored up there in the Southern Sierra than we did when we spoke less than a week ago. So this peak keeps getting higher and higher, and I think that it's probably getting close to the annual maximum. So it's either there now, or it might get yet even slightly higher next week with another modest but again very cold system, which will bring snow to the high elevations once again. Probably not a huge amount of snow, but additional snow nonetheless. And that, I think, will be the peak of the snow water equivalent for the season. So it is going to peak right around, perhaps slightly above 300% of the long-term average in the Southern Sierra, which will make it, by a significant margin, the largest snowpack ever recorded in that part of the state. So this really is saying something. It exceeds the snowpack that we had up there in 1982-83 winter and also the 1969 winter. So those were the benchmark years in terms of Southern Sierra snowpack, and this year exceeds it, and the numbers are still creeping up even higher. The reason I bring that up, of course, as I've been really emphasizing, is all of that water is going to have to come downhill sooner rather than later. As we enter April, it really is probably imminent, although I don't necessarily think it's going to happen in the next week. I think that the snowmelt and the runoff from snowmelt is going to start to accelerate in the next 7 to 10 days, given the forecast, and probably continue to accelerate thereafter. How quickly it does so is still unclear, but it does look like after next week there'll be a fairly pronounced warming trend with much milder temperatures in the Central Valley and lower foothills, even up into the lower 70s. So t-shirt and shorts weather, real spring-like weather finally, which is good news for a lot of folks who need it, but it does mean that the big melt is on the way. So next week, looks like what will happen is there is going to be a conspicuously cold closed low-pressure system that slides southward over California on Monday and Tuesday. And although it's going to be fairly moisture-starved, so this is not going to be a nice Pacific system coming in from the west or diving in from the northwest. This one's going to come in from the north, and it's going to be really cold air aloft for this time of year. There may be yet another round of unusually low elevation snow, although I don't expect it to be extremely heavy. It may be notable for the fact that it occurs at unusually low elevations. And it's possible that some lower elevation areas will essentially stay dry or mostly dry. So in the Central Valley along the coast, because this system will have so little moisture associated with it. But this is one of those scenarios where even if some folks stay dry, other folks could see pretty dramatic weather locally, because it'll be a very unstable air mass with very steep vertical lapse rates. Lapse rates being the rate at which temperatures decrease with height. The steeper they are, generally speaking, the more unstable the atmosphere. And even though it doesn't have a lot of moisture associated with it, that very unstable air mass may be able to overcome the lack of moisture and produce fairly widespread showers and thunderstorms with low snow levels, thunderstorms that produce hail even down to sea level, and maybe, again, as we've already seen this winter a number of times, a handful of supercell severe thunderstorms in the Central Valley, maybe in coastal Southern California, depending on the exact trajectory of the low. But so this is not a very high statewide precipitation accumulating system overall, but it could produce very isolated dramatic weather in the forms of isolated significant thunderstorms next week and low elevation snowfall. So again, some folks may stay mostly dry but cold and breezy when the system comes down next week. Other folks might see some sudden bursts of thunderstorms and hail locally. It's a little bit too far out to get in the details, but there could be another good cloud and storm watching day in the Central Valley, either on Monday or Tuesday next week. But aside from that, once that system moves through, that anomalously cold system with yet more snow in the mountains, that looks like it might be the beginning of the end in terms of California's very active season this year. Because after that, there is an emerging consensus in the multi-model ensemble world that conditions will gradually warm and that there really won't be much additional precipitation. There could still be occasional showers in the northern third or the northern quarter of California heading into mid-April, but it does look like, in general, a weak to moderate ridging will probably build in warming surface temperatures and keeping the majority of precipitation away from California after next week's cold system. So really we've got about another 5 or 6 days of active cold weather, and then things might change pretty dramatically towards warmer and less active conditions. And of course that is what you would expect this time of year. We've had a long sustained period of unusually cold and active conditions, especially cold in March. In fact, I think March will end up being the most anomalously cold month of the year, which is not usually the case in California, but I think it will be this year and across much of the West. I think that it's going to be probably a welcome reprieve for a lot of folks who have sort of struggled through a rough and sort of long winter in a lot of parts of California. And in general, this is good news. It means that the flood risk in places that aren't susceptible to runoff from snowmelt is going to plummet, essentially moving forward. So the likelihood of seeing significant flooding in the Bay Area and coastal Southern California and other places is going to drop precipitously now that the major rain season is likely over. That doesn't mean there can't be localized flooding if you get a thunderstorm downpour with these literal April showers, but in general, the risk of widespread flooding outside of snowmelt affected areas is really probably most likely to be a non-issue for the rest of the season. So that's the good news. And the likelihood of seeing damaging cyclonic windstorms, as we've seen 3 or 4 times this winter in California, really drops off a cliff, I think, moving forward. However, the big challenge, as I mentioned, is going to be in the Central Valley, and in particular in the southern half of the Central Valley, in the San Joaquin Valley, as well as in the Owens Valley, so on the eastern slopes and in western Nevada. So that really anything that drains watersheds on either the western or the eastern slopes of the central and southern Sierra Nevada. And so I think of all these places, the Owens Valley and the San Joaquin Valley are going to see the greatest challenges in terms of potential snowmelt flooding moving forward. And as I've talked about extensively before, there is already significant flooding. It's sort of at a steady state right now. There's still more water flowing in than can flow out of the Tulare Basin, for example. But right now, it's sort of at a steady state. But I think the challenge is we really haven't seen much snowmelt yet. In fact, again, there is more snow up there now than there has been at any point so far this season, a record amount. As that record Southern Sierra snowpack melts in the days and weeks to come, and it is going to do that between now and June. Most of it is going to melt and flow downhill. It's going to fill some of these Southern Sierra, these smaller reservoirs in the Southern Sierra multiple times over, which means that essentially those reservoir operators are going to have to release water continuously, potentially high flows, to maintain safety margins in these reservoirs and with these dams. And so there's going to be very high flows downstream of these dams, potentially uncontrolled flows. They may just essentially have to let as much water out as is coming in. So those dams may cease to function as flood control features of the flood protection system. And so you're going to see largely uncontrolled flows from some of the smaller dams in the Southern Sierra flowing into the San Joaquin Valley's eastern side, and therefore eventually downriver on the San Joaquin River all the way into the San Francisco Bay Delta. And so no one knows at this point exactly how high those flows are going to get, but to keep this in perspective, again, there is more water up there right now. The sum of the water currently in the reservoirs plus the snowpack, and you can thank Mike Dettinger's figures, useful figures on Twitter for these real-time updates, is greater than that in either 83 or 69, which are the two benchmark years for Southern Sierra snowpack. And both of those years produced major flooding in the San Joaquin Valley and then in the Tulare Lake Basin. So, this is it's never quite apples to apples, but if anything, it's apples to slightly larger apple this year. And it all comes down to how quickly the snow melts. If it's nice and gradual, again, it will be not as bad as if we get either a late season warm atmospheric river, even if it's a weak one, even if it's mostly just a warm, humid air mass with some drizzle or light rain. It's not so much the precipitation that's concerning at this point, it's the warm, humid air mass that would actually cause more damage probably in terms of transferring that energy from the atmosphere to the surface of the snowpack and to contribute to melting it. So that's one possibility. There's nothing on the horizon right now at all, but it remains a theoretical possibility through April and early May. We'll just have to see what happens. The other, perhaps more likely possibility is we do get an early season heat wave that affects the Southern Sierra and gets melt going in earnest as well. We do see warming temperatures in the forecast into the 70s in the valley and maybe into the 50s or 60s in the mountains locally looking out 7 to 10 days. Not necessarily heat wave temperatures. Those are not that unusual for April to see temperatures that warm. But if they start to get warmer than that, then we are going to see a further acceleration in snowmelt. But to be clear, those temperatures are more than warm enough to get the snowmelt started. So I've been talking about how this is a future tense problem primarily. As much flooding as there's been in the Tulare Lake Basin so far, that the peak was yet to come, and we're seeing indications that although the peak is not immediately on the horizon, that we're going to be on the upslope toward the peak now, starting later next week when snowmelt begins in earnest, which again hasn't really started yet. So we'll keep an eye out both for the major heat waves. Late season atmospheric rivers, even if they're quite weak, could be a big problem. Neither of those are currently in the forecast or on the horizon, but they're both possible, and that will be something that could cause problems if they occur at any point really between now and mid to late May. So that situation in the Central Valley and especially in the southern parts of the San Joaquin Valley or the central San Joaquin Valley, it's going to remain interesting, and there are a lot of communities that are still at risk. It's worth noting that there are other communities that are still trying to recover from pretty severe flood damages from earlier this winter, including Pajaro, along the Pajaro River, other parts, in other areas in the Salinas Valley that suffered levee failures and flooding earlier this winter. A lot of these, again, are low-income and agricultural communities, and the agricultural land itself has experienced significant inundation as well. And while in some ways it takes less time to recover that than major flooding in urban areas, it can still be disruptive. And I think the flooding we're seeing right now in Tulare Lake Basin and that we've seen recently in the Salinas Valley will affect agriculture for much of the rest of the year, just in terms of there being ongoing inundation in some places, whether it's because things have stayed damp and cool for longer and so there's increased risk of plant fungal infections, or just because there has been some damage to levees or deposition of sediment or drowning of initial plantings. All of these things could be disruptive moving forward for at least a little while. Maybe less of an issue in other parts of the state, in other agricultural growing regions where the weather conditions will probably rapidly improve in the coming days and weeks relative to what they have been. But in these other places that have been flood affected or that may continue to be experiencing flooding in the weeks to come, and again, that's really the various parts of the San Joaquin Valley, that's where agriculture is going to continue to be really disrupted throughout the spring and probably into the summer months this year as well, at a minimum, if not longer. Let's see what else is going on today. And again, please do feel free to add questions to the chat about what has happened so far this year, sort of where we are seasonally in terms of the snowpack, the potential spring snowmelt flood risk. Could talk about the storm next week again. And then also the last thing I wanted to mention before I start taking a closer look at these comments, and I think some of the questions are already coming in on this, is the growing signs that we're headed for a potentially significant El Nino event this summer and into next fall and winter. There's an enormous caveat, first of all, that we're still on the wrong side of what's known as the spring predictability barrier, which essentially says that there is something intrinsic about the way that the coupled ocean and atmosphere system works that makes predictions regarding what ENSO might or might not do on the other side of the spring predictability barrier quite difficult when it's still this early in the season. So in other words, you can make pretty good 3 to 6 month predictions about El Nino and La Nina starting in the summer for the coming winter, but it is harder to make accurate 3 or 6 month predictions starting in the spring. There is something about the spring where the initial conditions are noisier perhaps than they are in summer once a pattern has gotten established. So with that major caveat, there is a very strong consensus among the predictive models. In fact, I would say at this point it's essentially unanimous, as well as just basic theory about how the oscillatory behavior of El Nino and the broader El Nino Southern Oscillation works, that we're almost certainly headed for some kind of El Nino conditions by later this summer and into the fall. So that much is pretty clear. The intensity predictions, though, are still very much up in the air. There are theoretical reasons to believe that we might be headed for a major El Nino event, because we've seen, the persistence of La Nina for an unusually long period of time. That has tended to sequester a lot of heat in the West Pacific subsurface ocean, which may end up resurfacing as the water literally sloshes back eastward. Again, as I've talked about before, there is an actual slope of the ocean surface from west to east across the Pacific Basin, a noticeable slope when you look at it from satellite imagery, where the western half of the Pacific Ocean is a little bit higher than the eastern half. And when you have an El Nino event, that sea surface slope relaxes a little bit, and some of that water, that really warm water from the West Pacific, does slosh eastward a bit. That's not all that's happening. And really the main reason why there's so much warming in the eastern tropical Pacific during an El Nino event is because of the reduction in upwelling. So it's not that warm water moves all the way from the West Pacific to the East Pacific, but instead there's a complicated indirect causal chain of events that results in the usual wind patterns off the coast of Peru essentially to die down. The prevailing winds that cause upwelling of cold water from beneath tend to weaken during El Nino, and that allows water near the equatorial coast of Peru to get dramatically warmer. Well, that's exactly what we're seeing right now. In fact, Peru is currently experiencing severe rainfall and record temperatures in some areas because the ocean surface temperatures just west of the country have skyrocketed to well above average levels in recent weeks. This is very much indicative of the incipient stages of a significant El Nino event. So the real world and the atmosphere do appear to be cooperating and consistent with model predictions right now, and again, also with theory. So an El Nino of some magnitude now appears very likely beginning at some point later this summer, and probably almost, I would even argue, very likely persisting into the fall and winter. So this will probably be relevant for next winter's precipitation in California. But just how important this is really will depend on the strength. If it ends up being an El Nino event on the weaker side of the spectrum, it really isn't going to tell us very much about what might happen next winter. If it ends up being an El Nino event at the stronger end of the spectrum, particularly if it is very strong, then it might exert a dominant influence on next winter's precipitation and increase the likelihood of very wet conditions. But that's all a bit speculative right now because we don't know how intense El Nino will likely become. There's been some buzz on the internet recently regarding some, I guess we could call them very recent coupled model predictions. The latest round of predictions from the American seasonal model and also the Australian seasonal models depict a very strong El Nino event. But not all of the other global models do the same thing. Most of them agree on an El Nino of some magnitude. Some of them even suggest a moderate to strong one is possible, if not likely. But others don't. And so we're still in this uncertainty space where we don't know exactly how strong this incipient but probable El Nino event might become. But there are some hints, there are some unusually strong hints that it may be more than a weak one, and it could potentially be a strong one. And that's about as far as I'm willing to go down that road right now, because as I mentioned, we are on the wrong side of the spring predictability barrier. Things could change, although I would be essentially shocked at this point if we ended up with another La Nina year next year. That much is pretty clear. That's not likely on the table for next season. I guess nothing is impossible in the Earth and the Earth's climate coupled ocean climate system, but that would be something I would strongly bet against for next year. So we're likely headed towards an El Nino of some magnitude, but just how strong it will be really does affect what that means for California, if anything. It may not mean very much if it's a weak one. It could mean a lot if it's a strong one, and there is at least some possibility it will be a strong one this time around. So stay tuned for that one. All right, I'm going to start looking through the questions now. Let's see here. Yeah, there's a lot of comments. I've been seeing this recently. This may end up being a good wildflower season throughout a lot of California, since pretty much everyone's gotten wet, including the deserts and the grasslands. And so there will probably be some, it's been a little bit too cold, I think, for some of these to start yet. But now as things warm up in the next 7 to 10 days, I think that we'll probably see a lot more of the pretty cool and widespread colors popping up. Especially since this is coming on the heels of a severe drought, so whatever seeds may have been dormant for a long time will be encouraged to germinate this year. Let's see what else here. Yeah, some questions about El Nino. Question about potential for thunderstorms next week. I think that the potential for thunderstorms next week, with next week's moisture-starved but very unstable and cold system, are actually pretty high. And as I mentioned, there's even this pattern recognition tells me that this is the kind of pattern that does result in isolated severe thunderstorms and supercells, particularly in the Central Valley. So again, there probably will be at least one very good cloud watching day in the Central Valley and maybe coastal California next week. Could be anywhere between about Monday and Wednesday, depending on where you are in the state. It's a question about how we hear a lot from Brody about how we hear a lot about temperature and precipitation in a warming climate, but what about winds? Do we see anything like higher average wind speeds or potential for higher max wind gusts? This is really interesting and is actually an extraordinarily complicated question. And the short version of it is somewhat surprisingly, we don't know. The slightly more nuanced answer is there's long been some evidence of potential for what some folks have called global stilling, where on average globally wind speeds decrease slightly in a warming climate as certain temperature and pressure differentials weaken on average. It's not totally clear if that's actually happening or even if that's a correct prediction. We don't really have a great theory as to how this should evolve. So it's not like temperature, where obviously things are getting warmer because we're trapping more energy, by the emission, the increasingly thick layer of greenhouse gases. That much is clear. And it's not like precipitation, where we have a very clear thermodynamic theory, the Clausius-Clapeyron relationship, the increasing atmospheric sponge capacity I always talk about, where the water vapor holding capacity of the atmosphere expands exponentially with warming. We don't have a great fundamental theory for how winds should change. Climate models generally show weakening of average winds on a global basis, but they don't fully agree on that. And then when it comes to extreme winds, then it might be a completely different picture, because it depends what kind of winds we're talking about. In some places regionally, winds could increase, and other places they could decrease. Globally, they might decrease slightly. But here's the thing. There's strong evidence that the strongest winds in tropical cyclones, so for hurricanes, for example, are increasing and will continue to increase in a warming climate. So the very strongest winds on Earth will probably get even stronger. There is some emerging evidence, and again, this is even more speculative, that certain kinds of winds from severe thunderstorms and tornadoes, not that we get a tremendous amount of tornadoes in California, but that those on a global basis could potentially increase in a warming climate as well. And then the question about the kinds of winds that are most relevant in California, the synoptic scale cyclone winds, like the ones we've seen this winter, and also the downslope winds that we tend to see in autumn, the ones that are so scary from a fire weather perspective. The answer is we don't really know how those might change, how extreme winds from winter storms might shift or extreme downslope winds might shift. There just isn't a lot of high quality evidence pointing in either direction for those sorts of events. So there's some modest evidence that on average global wind speeds will slightly decrease, but that the extreme winds from things like tropical cyclones and severe convective weather will probably increase. And regionally, it's probably going to vary whether extreme winds from ordinary extratropical or mid-latitude storms increases, as well as these kinds of downslope winds we see in the autumn with fire weather. There's even some slight evidence that those might, that the average intensity of those downslope winds could very slightly decrease, and throughout a lot of places in the American West, but that the most extreme events might actually stay just the same or increase slightly, and in fact the seasonality may broaden. So there's a lot of moving parts there. We don't have a good theory regarding winds in general, and the details actually matter a lot. There could be a difference between local and global trends, and also probably more importantly, there could be a divergence between mean winds and extreme winds caused by different phenomena, where one could decrease and the other could well increase in the same place. This is not entirely dissimilar from other things that we're seeing where there's divergence between mean changes and extreme changes. This is certainly true for precipitation in California, where, for example, in California, there hasn't been a real long-term trend in mean precipitation, and there may not be even in a much warmer world, even as we see much more intense individual precipitation events, stronger individual atmospheric rivers, and more extreme wet winters. If you mathematically counterbalance that with drier conditions the rest of the time, then your average might come out to be similar, but you actually have a very different precipitation climatology. It's possible the same thing happens with winds, although we don't understand the causal mechanisms with winds nearly as well, and so that's still something that's really kind of uncertain. It's an important thing, and it's another illustration of there's some folks are like, well, what else is there to know about climate in a warming world? I mean, it's like, well, actually quite a lot. There's quite a lot we don't understand very well. The basics aren't really going to change. I mean, it's pretty unlikely that we're ever going to get evidence that overturns the extremely high confidence that the Earth is warming and that human activities are the cause of that warming. But when it comes to the details, there's a lot, frankly, that's still unresolved in terms of regional hydroclimate, extreme events, and things of that nature. Really, all the kinds of things that we talk about in this setting and that affect people on a day-to-day level. So there's plenty of work still to be done. I don't think any of us climate scientists are going to be out of a job anytime soon for lack of interest or for lack of need of this kind of information. I guess that's one way of looking at it. But good question about winds. The very short answer is I don't know, and the much longer answer I just gave is why it's complicated and why we don't have as good a sense as we do for temperature and precipitation, which is probably why you don't hear about it as often, because you don't have as much to say about it. A question about whether I have any specific information for the Kern River and Isabella Dam. The answer is no, although I will point out that there have been a lot of erroneous rumors that have circulated this winter online regarding watersheds in the Southern Sierra and prognostications for catastrophe that did not materialize. That's not to say that serious events couldn't unfold moving forward, but I do think it's an illustration of the fact that it's really important to listen to trusted sources there, and not to get too caught up in internet rumors. I mean, this is true generally, but I think this for whatever reason, this region has been really susceptible to it this winter. This is a concern, though. I mean, as I mentioned, there is going to be very high runoff that may exceed the ability of these structures to offer flood control. That does not mean that the structures themselves are necessarily going to have structural problems, but what it might well mean is that the operators of these dams, they're going to have to set inflow equal to outflow, meaning that it's essentially just whatever Mother Nature throws at us, that the dams no longer have really any ability to buffer flows. And so if there's extreme runoff, there's going to be extreme outflow from the dam, and there's going to be severe flooding downstream of that. So that's not a specific prediction, but it's something that could happen. But I would advise folks to stay tuned to the official sources, because honestly, I don't have detailed inside information about these things. Everybody's paying close attention, but we're just going to have to see how it goes. There is the potential for some issues on these watersheds for sure, and they could be significant, but that's about all we can say right now, because it's really going to come down to how quickly does that snow melt. Let's see, continuing down the questions list here. Alright, they're coming through now, quite a few. Alright, let's see here. Yeah, another question from Sean about thoughts on smaller, uncontrolled seasonal rivers in the Southern Sierra. Anything that has a significant snowpack upstream of it right now is potentially going to be a problem. This is particularly true for uncontrolled watersheds. Some of these watersheds do respond, the smaller, flashier ones respond faster to intense downpours than they do to snowmelt. So in these watersheds, there might not be severe flooding upstream, but then the problem becomes what happens when these empty into the valley and the waters slow down and tends to accumulate more. So even if the peaks aren't extremely high, if there's sustained very high flows, then those start to accumulate downstream in the Central Valley and cause bigger problems. So that is sort of where I'd expect the biggest problems to be. There may be very high runoff in the foothills and mountains that is manageable largely at those locations, but becomes unmanageable downstream in the valley, again, when these waters and these flows converge and accumulate. So that would be the big concern there. A question from Charles about how or whether evapotranspiration from soaked Sierra Nevada soils, presumably, can ameliorate drought conditions in the Great Basin. So not talking so much about the drought, I guess, in California, which has indeed been severely reduced by this winter's precipitation, but sort of thinking like about the downwind effects, I'd imagine. And that's a good question. I suspect the answer is at least partially yes. I don't know exactly the degree to which we kind of have to run modeling on that, but the basic idea being is if you kind of have an unusually abundant supply of moisture, both in the Sierra and then probably more importantly on the immediate leeward side of the Sierra, then is there more moisture available for precipitation during, say, the monsoon season, which is usually composed of deep moist convection and thunderstorms. Theoretically, yes, there should be more moisture available. There can be some negative factors, like if you can't get the surface as hot because it's damp and you have to expend a lot more solar energy evaporating water, you don't get as much atmospheric instability, and so you don't get as many thunderstorms that way. But I think the dominant effect, if there is one, would probably be to improve things because of the unusually abundant availability of moisture upwind of these areas. It's kind of speculative, but it's an interesting thought, and it might be relevant. And it's also worth noting that there's actually been a pretty good snow season across most of the lower Colorado Basin and the Great Basin as well. So even just that is likely to do some work toward ameliorating at least the short-term drought conditions. The long-term drought in the Colorado Basin is a whole different question. This is good news, but it really doesn't change the big picture there in the long run. But in the short term, it does change the picture, I think, in a lot of places, especially in California, where the intrinsic timescales of drought in California are shorter. California hasn't really had multi-decade droughts in living memory. As severe as they've been relatively short, several years long, very intense, historically intense, and this is largely because it's a smaller watershed. I mean, there are no rivers as long as the Colorado River in California. Of course, the Colorado River forms the southeastern border of California in the desert, but generally I'm talking about the rest of the watersheds. They're all smaller and faster responding, and so the intrinsic timescale for drought is shorter but sharper droughts in some ways. And so a really good year in California does more toward ameliorating the drought conditions in California than a single really good year does on the Colorado Basin, because that drought is just so much deeper seated over many years and even decades. California's recent droughts have been really more multi-single year droughts, and so it's a little bit easier to dig out of them. So I think the situation in California is somewhat different from in the Great Basin or in the Colorado Basin more broadly. Let's see here. All right. A question about there was a graphic tweeted by the Scripps Institute, which keeps track of atmospheric rivers in California. It's sort of their subspecialty on hydroclimate extremes there. And they show that this winter along all of the west coast of North America, there were around 30 to 33 atmospheric rivers that made landfall. About half of those made landfall in California somewhere, which is an unusually high number. So there were probably 16 or 17 landfalling atmospheric rivers in California this year. That compares to, in a drought year, we might just see 2 or 3. So 2 or 3 in a drought year versus 16 or 17 in this very wet and active winter gives you a sense of how much more active this year has been than some recent years. The other thing I wanted to focus on, though, is that as disruptive as some of these storms have been, as far as the atmospheric river intensity scale goes, none of these atmospheric rivers that made landfall in California were of the extreme to exceptional intensity. So there were several that were strong, moderate to strong, but none of them technically reached extreme or exceptional scales. So there's really 2 tiers above any of the atmospheric rivers that made landfall in California this winter. And this is a point that I've been making to a lot of folks, which is that this year it was the cumulative number of events, as well as their relatively close sequencing at times, along with the fact that they all produced tremendous amounts of mountain snowfall for the most part, that they were pretty cold atmospheric rivers generally speaking, that made the difference. They were also attached to fairly strong low-pressure systems in some cases, and this is where all the wind damage came from. So the atmospheric river intensity scale was not taken into account the wind damage potential. So ignoring that for a moment, it's really a metric of how much water vapor transport was actually occurring in these atmospheric rivers. And we saw multiple strong ones, but none that were extreme or at the very high end exceptional. I think that's important context because this year could have been a lot worse. Imagine if we had thrown in a couple of extreme to exceptional events in the mix with the kind of winter we had. Well, that would have made these problems, the flood problems that we've seen, pretty dramatically worse than they have been. So as significant as the flooding has been, it's much less bad than it could have been had we had an extra extreme to exceptional atmospheric river or two at some point. And this is sort of why we have these Arcstorm scenarios that I keep talking about. So in Arcstorm 2.0, both of the scenarios include at least one or two extreme to exceptional atmospheric river events embedded in a month-long sequence of moderate to strong storms like we did see this year. What we didn't get were the, I guess you'd call them the cherry on top, the exclamation points, which really would have changed the game in a scary way. In the Arc Future scenario, we get a bunch of extreme to exceptional atmospheric rivers in a month-long period. And again, keep in mind, we didn't even see one of them this entire winter. And in the Arc Future scenario, we see multiple of them over the course of a similar month-long period of time that we had to this month-long peak in December to January this year. So, this is food for thought in terms of how what we've seen recently is a big deal, but it's far from the plausible worst-case scenario. And climate change is increasing the likelihood, in particular, of extreme atmospheric rivers. It may not be increasing the overall number of them. They're still going to vary a lot from year to year. It's even possible that the overall number of atmospheric rivers decreases, but it looks like the decrease is mainly going to come at the weak to moderate end of the spectrum, and that we're going to add to the extreme to exceptional end of the spectrum. So a shift from the more beneficial kinds of atmospheric rivers that bolster water supply and bring increased snowpack, and an increase in the kinds of very high-end atmospheric river events that primarily cause harm through flooding. That is the expectation in a warming climate, and as I've mentioned before, I think it's a likely estimate for the degree to which historical warming thus far has contributed to the intensity of the more significant atmospheric river events in a year like this one is probably on the order of anywhere from about 5 to 15% wetter than they would have been in a cooler climate. That's a fairly wide range, but with a central estimate maybe around 10% if you want a single number, that's still fairly significant. And you can hear Luna barking in the background. I think somebody might be delivering a package now. But the long and the short of it is that we're going to see more of these very wet storm sequences and these extreme individual atmospheric river events moving forward. So I think the season is almost done this year. The likelihood of seeing very intense atmospheric rivers moving forward is low. I mean, they tend not to happen in California after March, but there could still be weak to moderate ones the rest of the season, and if it's a warm one, that could cause some problems with southern Sierra snowpack, even if it's not very strong at this point. All right, continuing to look at the questions here. Yeah, just going down the list. Yes, let's see here. Just a question from Ferg, more specifically about the Arcstorm 2.0. I did briefly cover this, but to be a little bit more specific about how what we've seen this winter compares to Arcstorm 2.0, we have two scenarios in Arcstorm 2.0, which I've mentioned before. The more modest arc historical event, which is essentially the about a once-in-a-century event in our cooler climate of the early 2000s, and the Arc Future event, which is a once in every couple centuries level event in a much warmer climate. And of the lesser Arc historical event, we maybe got about 80% of the way there during the peak of this winter in December or January on a statewide precipitation basis, but probably only got about halfway to the runoff that we would have seen in that event, because it occurred following a severe drought, so the reservoir levels were low, the soil moisture was low to start out with. B, the precipitation accumulations were about 20 to 30% lower than they would have been in that arc historical event. And C, they were fairly cold storms to begin with, and so we didn't see that immediate runoff. We just saw a huge amount of snowpack accumulation that's going to melt later. So it was about 70 to 80% of the precipitation in the weaker the weaker arc historical event, and maybe about half of the runoff from the weaker arc historical event. In terms of the stronger arc future event, we were even further from that, maybe only about half of the precipitation intensity. So literally, take what we saw from December to January and double it over a 1 month period. That would be closer to the precipitation that we'd see in the arc future event, or a scenario like it. And we probably only saw about a third to half of the runoff that we would see during that level of event this winter, because A, the precipitation intensity was perhaps only about half of what we would have seen in that kind of event, and the storms are much colder than the ones that we would expect to see in the future. And so that runoff would be compounded not only by precipitation that is nearly twice as much, but also by snow levels that are way, way higher, with far more immediate runoff from the mountains rather than lagged runoff in the spring that we're seeing this year. So essentially, we got a taste of significant flooding again in California, but it's still nowhere near what we would expect to see during an Arcstorm level event, either of the two scenarios, even the lesser of the two, but especially lower than the Arc Future scenario, which is much more extreme than what we've seen this year. All right. Well, it looks like the questions have slowed down. I may make this a slightly shorter session. Give myself a tongue twister there. I'm going to be at UC Davis next week, so there may be a pause in the live office hour session since I'll be seeing some folks in person at UC Davis. And also because finally it looks like the weather is going to calm down next week, so we will have that unusually cold and unstable air mass to start out the week. Could be some interesting Central Valley thunderstorms. Might even get to see a couple of them up there. But after that, it looks like things really are going to calm down and start to warm up, which is good news for everybody except perhaps for folks in the San Joaquin Valley and in other places that are vulnerable to snowmelt, because the big melt cometh. It's on the way, and it looks like it's coming sooner rather than later. So still no big, huge, enormous, scary melt events on the horizon. I don't see any big heat waves or any major storms that would cause them in the next week or two, but we're going to be on high alert for those kind of events really for the next month or two, so all the way through May. So stay tuned, enjoy the hopefully less disruptive weather, and let's keep an eye on that snowpack in the days and weeks to come. Thanks for joining me, and see you next